We're going to continue graphing in standard form now. Identifying the slope and y-intercept of each equation. Now this one is not in slope-intercept form. If it was in slope-intercept form, we could do that really easily. This one is in standard form, so we actually can't figure this out right now. We have to actually change this equation around to slope-intercept form to be able to see the slope and the y-intercept. To do that, all we have to do is solve for y. So subtract 4x from both sides. Maybe I'm going to zoom in just a little bit. Okay, subtracting 4x on both sides cancels that out. We're left with a negative 2y equals, and I can't combine the negative 4x and the 12 since they're not like terms. And I'm going to put the 4x first because when I have an x variable, I like it to be at the front if possible. Then divide by 2, and I'm going to divide by 2 on all 3 parts. That's actually a negative 2. I'm dividing that on all 3 parts. So y equals, negative 4 and negative 2 actually simplify to a positive 2. Negative 4 divided by negative 2 is a positive 2. X, and then it'll be a minus 6. So this means my slope is 2, and my y-intercept is negative 6. You can try this one on your own with a pause here. Otherwise, I'm going to go right into it. Again, we're solving for y. So I'll have 7y, because these cancel out, equals 7x minus 28. Divide by 7 on all 3 parts. Oh, I said 3. Okay, divide by 7 on all 3 parts. Those cancel out. I'm left with y equals, cancel, x minus 4. So right now, it doesn't seem like I have a slope, but there's really a 1 in front of that x. So it'll be m equals 1 for my slope, and then my y-intercept, or b value, is negative 4, and I am done with that. Next it says, write the equation of y plus 3 equals 4 times x minus 1 in standard form using integers. So now we're doing standard form. Okay, we need to write this in standard form. So to do that, we have to just arrange it. We're going to have to distribute, and then we're going to have to move the x and the y on one side, and then just a number by itself, like we have up here, on the right-hand side. So let's do that. Y plus 3, I'm going to bring that down. We'll have 4x minus 4. Okay. I'm going to move the 4x over to the left side, so I'll say minus 4x on both sides. So now we'll have a minus 4x plus a y plus a 3 all on the left-hand side. And since those cancel out, we're left with just a negative 4 over there. So now I can minus 3, minus 3. I kind of ran out of room, so I'm going to move over here. I'll have a negative 4x still over on that side, plus y. And then the 3's canceled out, and that equals negative 7. And we are done. I'm going to zoom in a little bit on this one for more writing room here. But we are adding 5 right off the bat. Oh, no, we're not. Sorry, we're distributing. We're distributing. So y minus 5 equals negative 3x plus 2. So now we can... Oh, I forgot. Sorry. I have to distribute over here as well. So it's got to go to both parts. So that would make it a negative 6. Then we can add the 3x over. So we'll have a 3x, a y, and a negative 5 over there. These cancel out. We'll be left with negative 6. We can add the 5 over. So we're left with 3x plus y equals negative 1. So what we're really doing here is just moving these things around to make them look like what we need. So that one is in standard form now. Okay. Now we're on to some story problems. It says Max sells lemonade for $2 per cup and candy for $1.50 per bar. So 2 keywords here. We have per twice, which means we're going to have something being multiplied by C, or for cups, well, whatever that one is, and then we're going to have something multiplied by bars. This is a total, and that usually it goes by itself. That's like the number in these equations, these standard form equations that are by themselves. So it says write a linear model where X stands for the number of cups and Y stands for the number of candy bars or bars. So we need this 425 to be by itself, which means this one is out because it doesn't even have a 425. This one kind of has it by itself, but not really, so it can't really be that one. And then the last one does have 425 by itself. So then it just comes down to the first two. It said it was $2 per cup, which would make sense with A, and then $1.50 per bar, which would make sense with B, or I'm sorry, with the second part of A. So that means it must be A. Down here it had $1.50 per cup, and it had $8 per candy bar. That $8 wasn't even in the problem itself, so it can't be letter D either. Last one here. Like I was saying before, we need that 25 to be by itself. That's a total, I can already tell off the bat, but I'll read the problem anyway. Each book in a bookstore costs $8 and each pen costs $3. If you want to spend exactly $25, write an equation in standard form modeling the situation. So, somehow this has to equal $25. It says let X represent the number of books you buy. Well, each book costs $8, and that's going to be for however many books you want to buy. Plus, they're going to add on to your total here $3 for every number of pens you buy, which was Y. That's our final equation for that one. And it looks like we are actually done with this for now. So, yeah, make sure you ask questions if you have any. That should do, you should be able